Hello students, this is Dr. Henk and I'm going to be actually introducing the biology and conservation side of our class, Biology and Environmental Science 495, Conservation and Economics in the Amazon. Let's start with this image. So my question is, who is this? It's not Santa Claus, and also it's not an old guy with a long beard and he's bald. Okay, let me show you another picture. What about this one? Who are they? He is not bald and he is wearing glasses. Any thoughts? Okay, I'm pretty sure that most of you guys have recognized Charles Darwin, and Darwin is well famous for his discovery of evolution by natural selection. But what about Wallace? So how many of you guys have actually recognized Wallace? Anybody? So Wallace did the same thing. He independently discovered the theory of evolution by natural selection. But nobody actually gave credit to Wallace. Why? Darwin published his work, Wallace did not. So technically, it should be Darwin-Wallace theory of evolution by natural selection, right? Okay, so I don't want to actually start this debate, but let's talk a little bit more about Wallace. So this guy, he actually spent most of his research career in rainforests, mainly in Southeast Asia and South America, studying birds, insects, and plants. And I want to emphasize this quote from Wallace to illustrate the biodiversity of rainforests. So with this lecture, we are going to be focusing on global patterns of biodiversity, and the distribution of it, and eventually we'll focus on where we are going. Okay, so let me give you a chance to read this quote. Okay, so the take-home message is, if you go to a rainforest and you are going to have a hard time finding two individuals of the same species. At the same time, we know that rainforests are not like deserts. They are full of life. So if you logically combine those two statements, you may realize that rainforests have a huge diversity of species. And that's one of the main focuses of this class. So let's learn a little bit more about biodiversity. Okay, let's start with this figure. So where do you see the most species? It's a very simple graph. The x-axis is number of species and the y-axis is the latitude. And you may recognize this zero latitude as the equator. When you move north from the equator, you are essentially reaching the North Pole. When you are reaching down, you are actually moving towards the South Pole. So do you see any significant large-scale patterns of biodiversity here? Yes. So most of the species are actually distributed along the equator. More species along the equator, less species towards poles. And we call this latitudinal gradient of biodiversity. And again, do you make the connection? So we are going to a place close to the equator. So you would expect lots of species. And let's make it broad. So how many species in the world? Any guesses? Let me show you. So this is a very brief summary. So we are summarizing 4 major groups, and this actually combines the rest. So invertebrates, these are species without a backbone. Fungi, chordates, these are mainly species with a backbone, including us, and plants. And in this graph, the y-axis is the number of taxa, and y-axis actually shows the 5 different groups. Green is described so far, so they have a scientific name, and white is undescribed. So essentially, according to this estimate, there are about 7 million species of invertebrates, and we have discovered only about 1.5 million. So we have long ways to go. With chordates, we are pretty good with chordates because we have estimated close to about 1 million, and we have discovered probably 70% of them already. Plants, relatively good. Now I'm going to expand this chordate data. So you can see fish, amphibians, birds, reptiles, mammals, and some lower chordates. So still, although we have discovered and described about 70% of them, still there's more room to grow, right? So the take-home message is there are so many species in the world, and we have discovered a fraction of it. So we still have to find and name these undiscovered species. So it's overwhelming, right? And most of this biodiversity is actually represented in tropical rainforests. And in this map, you can actually see all the tropical rainforests in the world, and they are distributed in the tropical belt. Landmass wise, it's about 7%. But if you think about all the species on planet Earth, all the described species, rainforests actually harbor about 50 to 90% of all the species, 40% of all the plants, and 30% of all the birds. And we are still discovering new species. Okay, now let's focus a little bit more on where we are going, the Amazon region. And each of this graph actually shows the species richness, or the number of species in 4 different groups of organisms: amphibians, birds, mammals, and plants. So do you recognize any major patterns? So in this case, more warmer colors represents more species. For an example, let's talk about birds. You know that I like birds. Okay, so the entire Amazon basin is a hotspot for birds, right? But let's talk about amphibians. So mainly, western part of the Amazon basin is the hotspot. And again, when it comes to mammals, it's mainly the southwest part of it, and also the northern Amazon. Plants, and you can see it's mainly the northwestern part of the Amazon basin. But can you recognize one place where you get an accumulation of all these 4 different groups of amphibians, animals? In other words, where do you see the hottest of the hotspot of biodiversity in Amazon basin? It's actually the western Amazon, right? And do you see this little spot right here? That's one of the hottest of biodiversity hotspots, and that is Yasuni National Park in Ecuador. And now I'm trying to compare the number of species with United States. So if you look at these numbers, the numbers for the area in square kilometers, United States is 1,000 times larger than the Yasuni National Park. But let's compare the species. So for amphibians, 150 for Yasuni and 295 for United States. Reptiles, 121, but for United States it's 311. And same story goes on for birds and mammals. So basically there's a few extra species in the United States compared to Yasuni. But is this a fair comparison? So we are comparing essentially 1 unit of Yasuni with 1,000 units of United States. If you want to do a fair comparison, you must actually divide all of these numbers for US by 1,000 to adjust it for number of species per unit area. Okay, so I just did it. So this table represents the number of species per unit area. What do you think? Now we are comparing apples with apples. Do you get it? So when there's one amphibian in US, we would expect 450 or more amphibians in Yasuni. When there's one bird in US, there's almost 600 species of birds in Yasuni National Park. So it's even beyond imagination. So the point is there's so many species for a given area in tropics. And again, in Ecuador, where we are going, it's one of the hottest hotspots of biodiversity in the world. So I already used the word hotspot, but what are these hotspots? So this map actually shows global biodiversity hotspots. So in early 2000s, a bunch of scientists wanted to recognize biodiversity rich areas in the world so they can actually concentrate their conservation efforts to those areas. So they looked at two different aspects. The first one is the species richness, and the second one is degree of threat. So by analyzing a large data set, so they identified 25 biodiversity hotspots where you can expect the most species. At the same time, they are under immense pressure of going extinction. So if you really think about this particular area in South America, you see that there's two biodiversity hotspots. Tumbes Choco, that's one in the western slopes, and also we have the tropical Andes. And they didn't even access the Amazon because they don't have enough data. So essentially, we are going to visit tropical Andes hotspot, and also essentially this is the hotspot, the Amazon. So we'll be actually going to two different hotspots. Okay, now let's focus on Ecuador. So this map actually summarizes major ecosystem types in Ecuador. And we are going to flying into Quito, and it's actually in the interbasin of Andes. So there's a mountain range here, there's another one over here, so it's a valley. And then we'll start driving this way, and we'll end up somewhere over here. So when we are actually exploring, first we'll actually go through high Andean scrublands right here, and we call them paramo habitats. And then we briefly cross the cloud forests, and we'll be spending most of our time in rainforest in the Amazon. So let's spend a little bit more time going through these specific habitats. So this photograph actually represents the high Andean paramo. So you can see that it's high altitude, no major trees. Most of the trees are stunted, and it's cold, and in some high altitude you can expect snow. And the plant communities are very unique. And also, when the plant communities are unique, you would expect some unique animal communities. This is a really good area for hummingbirds. And later you would realize that we are going to be actually visiting one of those hummingbird reserves in this area. And then we'll drive over the cloud forests. So it's a type of rainforest, uh, but it's high altitude. And finally, we are going to be in Oriente, that's lowland rainforest. This is the rainforest, this is the Amazon. Okay, now let's talk some specifics about Ecuador. So now I'm actually comparing the total number of species of Ecuador with the United States. And please keep in mind that Ecuador is a country about the size of Arizona. But look at these numbers. So you can go all over the US and you may see 575 species of butterflies. But in Ecuador, such a small area, you will get 450. And they are still describing new species from Ecuador. Amphibians, more amphibians in Ecuador than in US. Reptiles, more reptiles. Birds, you can't even compare. 1600. And I'm really overwhelmed with this number. Mammals, there's quite a few mammals in Ecuador for such a small country. And fish and plants. So overall, there's more species in Ecuador than United States. So we are going to a small area, but our chance of actually seeing lots of species is pretty high. And these are even not the final numbers for Ecuador. So US, it's well studied. There's so many people studying all these different groups of animals, and we are almost done with describing, actually finding and describing new species. But it's a different story for Ecuador. We still have a higher chance of finding new species and describing them. So these are some examples. In 1999, very recently, they described this large ant pitta from Jokotoku region. What are the odds of finding a large mammal like this one? In 2013, they described Alinguito scientifically, and the story says that they actually found the first specimens in the local market. 2015, they described 2 new wood lizards. Aren't they pretty? Very recently, a few months ago, 2017, they described 3 new ground snakes. These guys are elusive snakes, and they live among leaf litter, and there may be more. And also, they've been describing so many new species of frogs from Ecuador, and this is the latest addition, Ecuadorian rain frog. And with that, I'm going to show you a few species that we may encounter during our field explorations. And also, who knows, we may actually see some undescribed species. Okay, so let's start with plants. So in Ecuador, an estimated 25,000 species of plants. And we are going to be surrounded by plants, and I'm going to show you some examples. And all of these pictures that I'm going to be using for the next few slides were taken by Dr. Marks from her previous adventures. Heliconia species. These are very unique flowers, and they actually open their flowers throughout the year, so it can provide a continuous source of food for hummingbirds. There are so many hummingbirds relying on these, and it's a very cool mutualistic relationship between hummingbirds and these Heliconia plants. Palm trees. You will see lots of palm trees in the rainforest. and some of them actually have spines. Why? Any thoughts? Yes, it's for protection from herbivores. And also you will see huge trees throughout the rainforest. And this is a very special one, and we are going to be actually visiting to this one. This is a spirit tree for a local tribe. And can you see how large are these roots? These are buttressed roots. They actually support the plant. And look at the scale. And more on plants. So there's over 3,000 fruits in Amazon, and we are actually using 200 of them. And you may have even tried star fruit. You can actually buy it locally. And we may actually see some tree tomatoes. Let's jump into mammals. So there's about 300 mammals, including 20 primates. So how many primates in US? We have none. So these are some common sites. Some Saki monkeys, squirrel monkeys, and woolly monkeys. And also we may see a pink river dolphin. It's a critically endangered species, and there's only few species of river dolphins in the world, and this is one of those. And pygmy marmoset is one of the smallest uh, primates in the world, and also sluts. So we may actually see one of these guys. And there's lots and lots of herbs. Herbs are both reptiles and amphibians. And who knows, we may actually see an anaconda. Birds. Ecuador is a paradise for birds. Over 1,600 species. And we'll try our best to identify all the species that we are going to be seeing, but I'll be very happy if we can identify 200 species. We'll be overwhelmed with birds. So these are macos, and typically you guys find these in zoos, but you will see them in wild when you go to Amazon. Aninga is actually a water bird, an aquatic bird, and you can even find them in US. But this beast, Hudson, it's a very unique bird. In the entire group of birds, this one actually sets the bar very high. Do you know why? Yeah, it's a beautiful bird, and it's a large bird, and they are fairly common close to rivers, but this is why. So how many of you guys agree with me on this statement? Birds are dinosaurs. I'm not saying birds are descending from dinosaurs. I'm saying birds are dinosaurs. So this is Archaeopteryx. It's a reconstruction of one of the fossils of first birds. So you can see they have feathers, they have um, a mouth full of tiny teeth. It resembles very much to a modern bird, but there are some differences too. So look at these. These are claws attached to wings. And let me show you something. This is a hearts in chick. Do you see these? These are claws attached to their wings. So hearts in chicks are just like those ancestral birds. They still have these claws, but as they grow, they actually shed these. But this is a really good evidence that birds are dinosaurs. So one of the major bird groups that we are going to be seeing is hummingbirds, and we are going to be actually visiting this lodge to see hummingbirds. And why don't we watch this short video clip of that hummingbird lodge? So you got an idea. Hummingbirds are a very special group of birds. So if you just sample this slide, so you can see that they come in various sizes and they bear their beak structure is very different. Some have longer bills, some have straight, some have curved. So this is a good indication of coevolution, and we will discuss more about this when we are actually over there. Okay, so let's keep moving. Additionally, we are going to be seeing some fish and bunch of insects. So when it comes to insects, so those are the most abundant animals on planet Earth, right? But it's just a matter of actually find them. So you may have to look closer to find these cool bugs. And also we are going to be seeing lots of termite mounds, and instead of the ground you'll see some termite mounds on the trees. Do you know why? Because most of the Amazon is flooding for the most part of the year. Okay, so that will lead us to talk a little bit more about the things that we are going to be doing in the field. So let me start from the list of the material. So you must have a field journal, bunch of pencils, a pair of binoculars, because when you are in the rainforest, there's sometimes your naked eyes are useless. A pair of gloves, and you're going to be doing some field work and you may need to touch things, so it would be nice to have gloves. And also we are going to be doing some math in the rainforest, so just pack a $2 basic calculator, and I'm going to be packing a bunch of field guides. These are the guides that we are going to be using to identify species. So field rules and expectations. Keep talking to minimum, because if you make loud noises, you're going to scare off all the cool animals that we are going to be seeing. And also please listen to your guide or your professors when providing directions. So basically, no unauthorized experiments. And also do not suddenly point if you spot an animal, because sometimes your sudden movement can actually make a huge distraction, and then we all are going to lose that opportunity of exploring that particular animal. And also when we are moving in the rainforest, typically there's very narrow passages and sometimes there's no passages, so it would be nice to move in a line, and we'll actually take turns to lead our way. More field rules and expectations, and we have to actually spend most of our field time to observe, to explore, to find things, not to chat about things. So if it is something extensive, we may have to actually hold it until we have a discussion, or even until our afternoon sessions. So you can actually jot down these thoughts or questions in your field notebook. And please use your field journal, because 15% of your grade is coming from these entries. So we will discuss more about this with a separate unit, but basically you have to keep very good records of your explorations when you are at the Amazon. So please use the field notebook. And I know that we most of are planning on taking pictures, so let's take turns, because animals typically do not pose for a long time. And binoculars, field notebooks, or pencils are must. So when you go out, you must have these. And more importantly, we are in a unique place. This may be your only visit to Amazon. So don't be grumpy. Let's take every minute to enjoy the scenery and explore something new and learn as much as we can. Okay, so a little bit more about field notebook. So typically, I would recommend Write in the Rain brand, because you can actually write in the rain. And we are going to be in the rainforest, so it would be logical to take something that is water resistant. And I've been using these field notebooks for years, and I'm very happy with this. And uh, any field note without a date, time, and a location is useless. So you must enter the date, time, and location when you are starting a new day or when you are visiting a new place. Habitat and vegetation, so you can describe or you can sketch. And under general commentary, you can make notes about the activities that we have done, discussions, questions, thoughts, maybe collect your data, just write down your data. And of course, species observed, how many. And also, when you are in the field taking field notes, sketching is one of the necessary elements. Let me show you some examples. So these are very nice field notes. So there's lots of information, date, time, location, some information about the habitat, species, their behavior, and there's some nice sketches. And these are actually examples of seasoned naturalists. And I don't expect you to do this, but if you can, that would be wonderful. Let's give it a try. Okay, so it's time to talk a little bit about the field research. So we are actually going to be estimating biodiversity of 3 locations. So when it comes to biodiversity, there's 2 major elements: number of species and number of individuals of each species. So typically we just focus on number of species, right? But if you do so, you are actually skipping an important element. Our goal is to study and compare species diversity between a virgin forest patch, a disturbed site, and a secondary growth forest. So we can actually see how the biodiversity changes between these 3 habitats. So these are some examples. Okay, so before we move into some equations, I'm going to show you an example. So I have 2 samples, sample A and sample B. Which one is the most diverse? Sample A, because there's 3 different species, right? There's only 2 species in sample B, and there's 3 species in sample A. So if you focus on the first element, the number of species, sample A is the most diverse. Now let's think about the number of individuals in each sample. So think what you are going to be doing in the field. So if you go to a particular location, you just randomly sample species, correct? So if you go to sample A, there's a high probability of getting this butterfly and keep getting the same species. So at 75% of the times, you'll get this single species, because this sample is dominated by one species, and there's 2 rare species, the dragonfly and the ladybug. So when the dominance is high, the diversity is low. In this particular sample, in sample B, we have 2 species, but what about the probabilities of finding a new species? It's pretty high, because there's a 50% chance of getting either the butterfly or the ant. So in that sense, sample B is more diverse. So there's an issue. So because of that, scientists have actually came up with some diversity indices. These are some simple equations where we combine both number of species and number of individuals of each species. So we can actually use Simpson's index of species dominance to measure the dominance. And also we are going to be using Shannon-Wiener index to estimate the species diversity. And you may notice that in both cases, we have this PI. So PI is the proportion of a given species that actually combines both number of species and the number of individuals of each species. So with that, let's go to Amazon and explore the biodiversity, and let's find some cool species and have fun. Thank you.